In this video, I am going to explain conservation of linear momentum. So according to the conservation of linear momentum, in the absence of the external force, the total linear momentum of the system remains constant. Means if there is no external force working on the system, then its linear momentum will be constant. There will be no change in the linear momentum. To prove this statement, consider two bodies. First one of mass m1, let it is moving with velocity u1. And second one of mass m2, moving with initial velocity u2 along to the same line. After some time, let both will interact with each other. And after the interaction, they will separate it. So after the interaction between them, their velocities are v1 for m1 and v2 for m2. So these are the final velocities of given two bodies. Here, initial linear momentum of both the bodies, Pi is equals to linear momentum of first body, means m1 u1, plus linear momentum of second body, m2 u2. So this is the total initial linear momentum before the interaction between them. After the interaction, the final linear momentum Pm is equals to m1 v1 plus m2 v2. To prove the statement of the conservation of linear momentum, we will prove Pi is equals to Pm. For that, let the force applied on first body due to the interaction is F1. So according to Newton's second law of motion, it is given by, there will be the change in the linear momentum of the first body written as m1 v1 minus m1 u1. If the time for the interaction between them is t, then it will be divided by t, because the rate of change of linear momentum will represent the applied force. During the interaction, let the force applied on the second body is F2, then according to Newton's second law of motion, the rate of change of linear momentum of second body, which is m2 v2 minus m2 u2 divided by t. Let this one is equation 1 and this is equation 2. As we know that from the Newton's third law of motion, there is equal reaction for each and every action. So here, according to this law, F1 should be equal to minus F2, because both are in opposite direction. Works action and reaction will work on the different bodies. And this is equation 3. Now from 1, 2 and 3 we can write m1 v1 minus m1 u1 divided by t is equals to minus m2 v2 minus m2 u2 divided by t. In next step, t will cancel out. So there is m1 v1 minus m1 u1 is equals to, as we multiply by this minus sign. So there is minus m2 v2 plus m2 u2. In next step, we will arrange in the proper way. So we get m1 v1 plus m2 v2 is equals to m1 u1 plus m2 v2. So this is final linear momentum of the system, and that one initial linear momentum of the system. So that means the total final momentum of the system is equals to total initial linear momentum of the system, which is the law of the conservation of linear momentum. Hence, proved. So that was the proof of this law.